Solve the rational inequality and then write the solution set in interval notation. We have 6 divided by 2 minus x, which is less than or equal to 1 over 2 minus x. So let's go ahead and take a look at this rational inequality. Before we find the interval boundaries, we need to make sure that we set this inequality to be 0 on the right side. So what we're going to do is we're going to subtract this term, 1 over 2 minus x, to the left side of the inequality. So we have 6 over 2 minus x minus 1 over 2 minus x, and that's going to be less than or equal to 0. So we have a common denominator, so in the numerator it's going to be 6 minus 1 over 2 minus x, which is less than or equal to 0. 6 minus 1 is 5, so that becomes 5 divided by 2 minus x, which is less than or equal to 0. So now we've got our goal with 0 on the right hand side, and so now to find the interval boundaries, we're going to write this as a rational equation, so 5 over 2 minus x, which is equal to 0. Now we do not have a variable in the numerator, so we're going to look at the denominator and set 2 minus x equal to 0. We're going to subtract 2 to both sides, so we have negative x, which is equal to negative 2. Divide both sides by a negative, and therefore x is going to equal positive 2. And now keep in mind that because this is in a denominator, this is a restricted value, which means we cannot plug that number into the denominator. It would make it undefined. Okay, so now we're going to draw our number line so that we can then determine what our intervals are going to look like. So we have 0, it's going from negative infinity to positive infinity, and we can see that the value of 2 is our boundary. So we're going to go ahead and then represent an interval 1, interval 2. For interval 1, we're going from negative infinity to positive 2. And then for interval number 2, it's going to go from positive 2 to positive infinity. Now let's go ahead and then test some points here. So we're going to use the rational inequality of 5 divided by 2 minus x and less than or equal to 0. So for interval 1, we can pick 0. So x is going to equal 0. We have 5 over 2 minus 0. Is that less than or equal to 0? Well, this becomes 5 over 2. 5 over 2 is not less than 0, so therefore it is false. So it's false for region number 1. For number 2, we're going to pick the value for 3. So x is going to equal 3. We have 5 over 2 minus 3. Okay, 2 minus 3 is negative 1. 5 divided by negative 1 is negative 5. And negative 5, is that less than 0? Well, that answer is true. Okay, so now even though we have a less than or equal to, the value of 2 is a restricted value. So it has to still contain the parenthesis 2, comma, infinity, and therefore that is going to be the solution. So let's go ahead and plug that in. We have parenthesis 2, comma, infinity with the parenthesis. Check our answer, and there is our result.